Hello students, after studying the nature of the roots of the quadratic equations, we will study the relation between roots of the quadratic equations and the coefficients. Roots you have studied. Roots means solution. Coefficients means values of A, B and C. What is their relation that we are going to see? Suppose there is one quadratic equation. I'll consider the quadratic equation ax square plus bx plus c is equal to 0. This is a quadratic equation and you know that you will get the two roots of it. I'll consider alpha is the first root and beta are the roots of this equation. I have considered two roots, alpha and beta are the solutions, are the roots of this quadratic equation. Now what is the relation of this alpha and beta and the coefficients A, B and C? So here if we will take the sum of roots, sum of roots means alpha and beta, so we'll get a relation of this alpha and beta. It is minus b upon a. So here you get one formula, one relation. Similarly, if you see the product of the roots alpha and beta is equal to, you will get the formula c upon a. These two relations are very important to solve the next examples. Let's see the example. The difference between the roots of quadratic equation x square minus 13x plus k is equal to 0. We have to find the value of k. Now we cannot solve it. So how we will find out the k's value? So here the relations between the roots and the coefficients will be helpful. So the process to solve this example, the given equations we have to comparing with ax square plus bx plus c is equal to 0. We'll get the a's value 1, b's value minus 13, c's value k. Here c is equal to k. Now we'll find out the sum of the roots, that means alpha plus beta and alpha into beta. So here I'll consider let alpha and beta are roots of the equations. So therefore alpha plus beta, what will you get the value of alpha plus beta? What is the formula? Minus b upon a. That means minus into minus 13 upon a's value is 1. That means 13. So alpha plus beta, here you will get 13. Now the next relation, alpha into beta is equal to c upon a. What is c here? K. A is 1, that means k. So alpha into beta, you will get the answer k. So this is a common process for the every example, which depends on the relations between the roots and the coefficients. Now we'll see the next step. We have got alpha plus beta is equal to 30, first equation, alpha into beta is equal to k, second equation. By given condition in the example, they have said the difference between the roots is 7. That means alpha minus beta is equal to 7. This I will consider as a third equation. First equation and third equation, it looks like a simultaneous equations. We can solve it by any method. So here I'll add equation 1 and 3. I'll get alpha plus beta is equal to 13. Alpha minus beta is equal to 7. After adding it, b will cancel. Here 2 alpha is equal to 20. Alpha is equal to, you will get the answer 10. Alpha is equal to 10. Put in equation 1. You will get alpha plus beta is equal to 13. That means 10 plus beta is equal to 13. So beta's value 10 will go on that side and you will get the answer 13 minus 10. That means answer is 3. So you have got the two values. Alpha is equal to 10 and beta is equal to 3. Put alpha is equal to 10 and beta is equal to 3 in equation 2. So alpha beta is equal to k. This is equation 2. Alpha is 10. Beta is 3. So k is equal to, therefore k's value would be 30. This is the solution. This is the value of a k. Now we'll see the next example. Example number 2. If alpha and beta are the roots of this equation, x square plus 5x minus 1 is equal to 0, then find alpha cube plus beta cube. Second, alpha square plus beta square. So here solution, comparing with ax square plus bx plus c is equal to 0, we will get a is equal to 1, b is equal to 5, c is equal to minus 1. Now we will find out the value of alpha plus beta. Alpha plus beta minus b upon a is equal to, b is 5, so minus 5 upon 1, that means minus 5. So here alpha plus beta you will get minus 5. Now next, alpha into beta is equal to c upon a. C is minus 1 upon a is 1, that means minus 1. Therefore alpha into beta is equal to minus 1. Alpha plus beta is equal to minus 5 and alpha into beta is equal to minus 1. Now we will see the alpha cube plus beta cube. We will find out this by the formula alpha plus beta bracket cube minus 3 into alpha into beta alpha plus beta. You have to learn this formula. Alpha plus beta's value is minus 5 bracket cube minus 3 into alpha into beta, it is minus 1. Alpha plus beta again minus 5. Minus 5 bracket cube, answer is negative 125. Minus minus minus, again you will get the answer 5 3s are 15 and it would be negative. Negative negative, again you have to add it, so you will get the answer minus 140. Therefore alpha cube plus beta cube, you will get the answer minus 140. Now the next one, alpha square plus beta square is equal to alpha plus beta bracket square, if it is square, minus, here you have to take 2 into alpha into beta. These identities we have studied in 9th standard. Is equal to, now alpha plus beta minus 5 bracket square minus 2 into alpha into beta, it is minus 1. So answer 25, 2 1s are 2, so here you will get the answer 27. Minus 5 square is 25, minus minus it will be plus 2 and addition of this 2 it would be 27. So alpha square plus beta square, here you have got the answer 27. Third example, sum of the roots of a quadratic equation is double their product. Find k if equation is x square minus 4kx plus k plus 3 is equal to 0. Solution, comparing this with the standard form, you will get the a's value. Observe this equation carefully. A would be 1. B's value is minus 4k. but C, it is K plus 3. You should understand this type of examples properly. So what is A, B and C's answers? So C would be K plus 3. Let alpha and beta are roots. So you will get alpha plus beta is equal to minus B upon A. What is B? Minus 4K. So minus 4K upon 1. So it would be 4K. Means alpha plus beta is equal to, you will get 4K. Now alpha into beta. Alpha into beta is equal to C upon A. C value is K plus 3 upon 1 is equal to K plus 3. Therefore, alpha into beta is equal to K plus 3. By given condition, they have said sum of roots alpha plus beta. These are the sum of the roots. These are double, it is double their product. Double 2 times their product, alpha into beta. Now we'll put the values. Alpha plus beta is 4K. 2 into alpha plus beta, K plus 3. Multiply inside the bracket. 2K plus 6, 4K, 2K. Transfer it on this side. So 4K minus 2K is equal to 6. Here you will get the answer. 2K is equal to 6. If you will transfer 2 on that side, so it will be in division, then K is equal to 6 upon 2. So K is equal to 3. Now the next part, form the quadratic equation from the roots given below. Means you will find out the 2 roots alpha and beta and you have to form the equations. So here to get the quadratic equations, we have the equation x square minus alpha plus beta into x plus alpha into beta is equal to 0. If you have the 2 roots, you can find out the sum of the roots. You will find out the product of the roots and you will put those values in this equation. You will get the required quadratic equation. Now we'll see the example. Example number 1. Suppose 1 upon 2 and minus 1 upon 2. These are the 2 roots. So you have to form the equation, quadratic equation by using these 2 roots. So solution, here alpha is equal to 1 upon 2, beta is equal to minus 1 upon 2. Therefore alpha plus beta is equal to, how will you get it? 1 upon 2 plus minus 1 upon 2, it will become 0. Alpha into beta, 1 upon 2 into minus 1 upon 2. What is the product of this? It is minus 1 upon 4. Therefore, required equation, x square minus alpha into beta into x plus alpha into beta is equal to 0. We will put the values in this equation. After putting the values in this, x square minus, here you got the answer 0. So 0x plus, here you have got the answer minus 1 upon 4 is equal to 0. So x square minus 0x, if you write, if you don't write, that is okay, minus 0x minus 1 upon 4 is equal to 0. Multiply this equation by 4, you will get 4x square minus 0 into 4, it is 0x minus 1 is equal to 0. Multiply by 4. So this is the required equation. Now we'll see the next example. Next example number 2. 3 plus root 5 and 3 minus root 5. These are the two roots of the quadratic equation and we have to find out a quadratic equation. So solution, let alpha is equal to 3 plus root 5, beta is equal to 3 minus root 5. Now we will find out the alpha plus beta and alpha into beta. Alpha plus beta is equal to, so addition of these two, so 3 plus root 5 plus 3 minus root 5. Purposely I have written alpha and beta's values are in this, so it is easy to add it. So what is the addition of this? 3 plus 3, that means 3 plus 3, 6, root 5, this will be cancelled, only you will get alpha plus beta is equal to 6. Now we will see the product. Alpha into beta, it is 3 plus root 5, in another bracket 3 minus root 5. It looks like a identity, a plus b in one bracket into a minus b in another bracket. So what it shows, what it gives, a square minus b square. That means a square, 3 square, by that using that identity, root 5 bracket square, so 3 square is 9 minus 5, root 5 square is 5, so answer is 4. So alpha into beta is equal to 4. So therefore the required equation, x square minus alpha plus beta into x plus alpha into beta is equal to 0. Alpha plus beta is equal to 6, alpha into beta is equal to 4. We will put this value in this, we will get x square minus alpha plus beta is 6x plus alpha into beta is 4 is equal to 0. Therefore, this is the required equation. Next type of example is the roots of each of the following quadratic equations are real and equal. Find k. The roots are real and equal means their discriminant, it should be 0. We have studied the condition. So here the process of solving this equation is comparing with ax square plus bx plus c is equal to 0. We will get the a's value is 3, b's value is k, c's value is 12. The roots are, what is given? The roots are real and equal. If they are real and equal, therefore their discriminant must be 0. Therefore, b square minus 4ac is equal to 0. What is b square? K square minus 4 into a is 3, c is 12 is equal to 0. So k square minus 144 is equal to 0. Transfer it on that side. So k square is equal to 144. Taking square root on both the sides, you will get k is equal to, if you will take the square root of on both the sides, so you will get the k's values plus or minus 12. Therefore, k is equal to 12 or k is equal to minus 12. Second example, kx into x minus 2 plus 6 is equal to 0. Solution, multiply this inside the bracket, you will get kx square minus, if you multiply by 2, you will get 2kx plus 6 is equal to 0. Now comparing with ax square plus bx plus c is equal to 0. we will get A's value is k, B's value is minus 2k, C's value is 6. Roots are real and equal. Therefore, their discriminant must be 0. So, b square minus 4ac is equal to 0. What is b square? Minus 2k. So, 2k bracket square minus 4 into a. A is k. C is 6 is equal to 0. Minus 2k square, it is 4k square. Minus 6 4 are 24, 24k is equal to 0. This equation you can divide it by 4k. So divide by 4k, you will get, if you will divide by 4k, so here only k will left. Minus if you will divide 4 6 are 24, k will be cancelled, so is equal to 0. Therefore k is equal to 6. Students, based on this video, you can solve the exercise 2.5 in your notebook. Now, students, in next video, we are going to start the applications based on these lessons, quadratic equations. So, before that, you have to study the practice set 2.1 to 2.5. If you study this practice set well, then you can solve. We will go for the applications, that means word problems. Now, if you have completed all those practice set exercises, please send me the feedback in the comment box. Thank you.